A partition of a number is a way of writing it as a sum of one or more whole numbers. For example, if n equals 1, the number is 1, you can only write that as 1. But if n equals 2, you can write that as 2 or 1 plus 1. If n equals 3, you can write that as 3, 2 plus 1, or 1 plus 1 plus 1. Now you might be asking, couldn't you also write that as 1 plus 2? Well, you could, but usually when we talk about partitions of numbers, the order is not important, so 2 plus 1 and 1 plus 2 is the same thing. Just like mathematically, it doesn't matter what order you add in. If n equals 4, you have several possibilities. 4, 3 plus 1, 2 plus 2, 2 plus 1 plus 1, or 1 plus 1 plus 1 plus 1. When n equals 5, you can write it as 5, or 4 plus 1, or 3 plus 2. Or you could write it as 3 plus 1 plus 1, or you could write it as 2 plus 2 plus 1, or 2 plus 1 plus 1 plus 1, or 1 plus 1 plus 1 plus 1 plus 1. And you can kind of see the strategy I'm using here is first write the whole number itself, then write it as sums of two numbers, and then start taking turns breaking each of those down. 4 plus 1, you can't break that down unless you break down the 4, but 3 plus 2, you could break down the 2 as 1 plus 1. Then this 3 can become a 2 plus 1 and that 2. And it can be a little difficult, especially when the numbers get big, to make sure you've listed them all. When n equals 6, we're going to have 11 possible possibilities. So everything from 6 down to 1 plus 1 plus 1 plus 1 plus 1 plus 1. The last one we'll do in this video, because these do tend to get away from us, is n equals 7. And in this case, there are 15 total possibilities. We start off with 7, 6 plus 1, 5 plus 2, 4 plus 3. Then start going through the variants of those. 5 plus 2 can be written as 5 plus 1 plus 1. 4 plus 3 you could turn into 4 plus 2 plus 1, or 4 plus 1 plus 1 plus 1. And then just keep going with that. Maybe some of the patterns start with a 3. I only found 13, which means I missed 2. I have to go check my notes or go through this again and figure out which ones I missed. So I miscounted. I still had 14. I just missed this last one here, which was my 15, 3 plus 2 plus 2. So the number of partitions, now we can count up. You see n equals 1, there's 1 partition. N equals 2, we have 2 partitions. N equals 3, there's 3, and then 5, and then it just kind of starts getting out of hand. So maybe we should organize the number of partitions in a table. For the first few entries, we can just count these up. There's 1 partition of 1, there's 2 partitions of 2, there's 3 partitions of 3, but then things diverge from that simple pattern. For the number 4, there's a total of 5 partitions. For the number 5, we have 1, 2, 3, 4, 5, 6, 7 partitions. Number 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 partitions. I already said for number 7, I did this in advance, and there were 15 partitions. And then for number 8, there are going to be a total of 22 partitions, and for 9 there are 30 partitions. So what kind of formula is this? It's none of our familiar patterns. In fact, this is its own pattern. If you could work this out, 10, 11, 12, 30, and so beyond, you find some pretty startling facts, is that this sequence increases quickly. If we say that P of n is the number of partitions of n, for example, then P of 1 is 1, P of 2 is 2, P of 9 is 30, which just means number 9 has 30 partitions. It might surprise you to learn that P of 30 is 5,604. So for one extra bonus point in the class, go ahead and list all 5,604 possible partitions of the number 30, just like we did here. Here's a pro tip: you're going to need a lot of paper, and I'm actually not going to grade it.